Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hi, I'm Mano Marks. I'm developer advocate on the Google Maps developer relations team. I'm here with Brendan Kenny, who is also on the team with me, and we're here to talk to you today about some of the latest experiments that we've been doing with incorporating HTML5 onto Google Maps. So these are very much work in progress kind of things, building off of some things you may have seen earlier in the summer when Brendan talked about his CanvasLayer work that he's been doing. So why don't, do you want to describe just briefly what we've been doing?
Sure. So the most recent thing we've been doing is taking a look at how to load, parse, and display some of the most common kind of geodata formats. So especially looking at shapefiles and KML. Right. And the main problem that you run into if you want to parse it, well, actually, there's several stages of problems. So the first thing you have to do is actually load them.
Right.
And you actually wrote that part. So if you want to talk about that.
So one of the things that we looked at back in the spring is looking at pre-parsing data on a server and then passing it into the browser for display. And we've had some really good samples about doing that. And it's been really fun. But we wanted to look at doing pure JavaScript in the browser solutions for this. And so what I've been looking at doing is loading in shapefiles and KML files, and then displaying them on top of Google Maps by parsing them in JavaScript and then passing that on to the Canvas layer. So the shapefiles are binary files. Actually, so those of you who know about shapefiles would know that it's an open spec. High-end GIS software and lots of GIS software basically can produce shapefiles. They actually there's many files that compose a single shapefile. I was looking particularly at the .shp, which describes the geometries, and the .dbf, which describes the attribute data. We weren't dealing at this point with projections, although that's something we want to deal with in the future. And so loading those in, HTML5 allows you to load in using XML HTTP requests. You can actually now load in binary files. So previously people had dealt with this by loading it in as a string, passing a string that is basically a binary string and then doing fancy parsing, but you can actually load in shapefiles, these shapefile formats as binary files instead of as text. And then I compared that with using KML, which is an XML data format. It's actually the most common geographic data format in the world. There are about 1 billion of them on the web right now. And so what we did was we took some zip code boundary data from the U.S. Census. So taking the Tiger Line data and just looking at, we're looking at like 100 polygons in Northern California, basically, just to get a sense of how that would work. And then I used a couple of open source libraries. There's shp.js, dbf.js for parsing each of those pieces, and then also using JSTS, which is a JavaScript port of the Java topology suite, to do the triangulation. So then why don't you talk a little bit more about what happens then?
Sure. So we can take a look at an example here that I'm running. This is loading a shapefile of those zip codes or what are they? The census something.
Yeah, zip code boundaries.
Anyway, basically zip codes. And so this is just loading the first 100 zip code areas in that file. and then displaying them. And this is actually doing the convex hull of that. So the smallest convex polygon that encompasses that zip code, which is useful for a lot of kind of questions about that area. And so what we're doing here is, as Mano said, we are actually using XML HTTP requests to bring in that file. You set the response type as array buffer, so you can get it as directly the binary data, and then stepping through it and parsing it to get at the actual data points. And from there, we pass it to JSTS right now and to do the triangulation. So the problem here is that we want to use WebGL to display on top of a map. If you've seen some of our previous GDLs or live sessions, you've heard us talk about CanvasLayer, and we had a session at Google I/O where we also talked about it. Just basically putting a WebGL canvas on top of a map so that we have access to that hardware accelerated, super fast geometry drawing capability on top of a map. The problem is that WebGL is intentionally meant to be low level and provide primitives that are extremely fast, but you have to then put together to do something more complicated. And in this case, it only draws triangles. And the problem is when you have a big polygon, usually in a shapefile, it's just...
well, you do points, lines, or triangles.
Sorry, yes. But the only filled shape is a polygon. You can't do quadrilaterals or any kind of higher number of polygon or vertex shapes. So in this case, the shapefile just has these polylines to define the borders of these zip codes, and so we actually have to triangulate them to get them into a format that we can draw. And right now we're using JSTS. We're taking a look at actually, I started porting the libtest, which is an open source version of the tessellation library from the OpenGL utility library back from 20 years ago, but it's still one of the best methods to do this, and we'll just have a nice JavaScript library when that's done, which will be great. So we can actually peek in here in the code. If we look at just a particular record, we can see kind of the format that we get. So once it's parsed and triangulated, we get this little we get an array of objects to draw, and within that we just have the information about there's kind of primitive level information. So for that particular polygon here, we've stored the actual zip code and other information about that, and this could be anything. So this was in the shapefile already, but it could be anything from demographic data to a reference to another shapefile, so we can pull in data that's particular to that zip code and cross-reference it. Then we actually have the binary data, and if we drill down here, you can see it's just a series of latitude and longitudes that's actually in normal lat-long space that we then take care of on the inside, and then we have the type polygon, and so this is where we can switch on things like polylines and point data, that sort of thing. And finally, we just have this uniform object that lets us, if you're familiar with WebGL, there's these uniform variables, which is how you pass data in on the polygon or on the triangle level to say, I want this triangle red, or I want this triangle associated with this value, and I can do whatever I want in the shader. And so that's how we actually render it. And then in CanvasLayer, we just loop over this array of polygons and just say load this list of data and then render that list of data. And so I think right now we're actually showing something like 200,000 triangles. So this is unsimplified data. This is direct from this shapefile, and it's a little hard to see when it's presented like this, but it actually shows at a full 60 frames a second on this. I think this is like a 2.5-year-old machine, so it's nothing it's a decent computer, but it runs really well. Is the thing I'm getting at.
And as you can see, these are rather blobbish-looking polygons. If you actually look at polygons, you can actually look up a particular zip code, US zip code, on maps.google.com, and it'll highlight the polygon for you. We don't do that in the Maps API at this point, but they're much more precise than this, and that's because JSTS uses, as Brendan mentioned, this convex hull. algorithm, which creates a more simplified polygon that contains the polygon. So you can see it looks very roundish. This doesn't work well at all for concave polygons or polygons that have holes in them, which actually you can tell that this does because you can see there's an overlapping polygon.
Yeah, and if you have data that, or polygons that self-intersect, then you're really in trouble.
Yeah,
in fact, I think,
right.
I don't think, at least we haven't found any JavaScript triangulation library that handles self-intersection, which is why we're turning towards these other libraries, which can be a little bit slower, but are proven correct in almost all situations and are also like extremely numerically stable and that sort of thing. So, so it's not that exciting, but you can actually see the same thing over here. And this is parsing the KML file. And so this, are you using you're not using a binary load here, you're using something slightly different,
I just
right?
loaded in as XML.
Okay.
And we get better performance with the binary, loading in the binary shapefile and parsing that than the KML. Not significantly, but we're only working with about 100 polygons here. So I think you'd see much longer load times if you're doing all of California.
Right. Oh, yeah, that's a good point. I mean, the slowest part is triangulation because
absolutely.
These things are tens of thousands of vertices, and so you have to, at the very least, you're going to have that order of triangles, and often you have much more if it's more complicated. But with KML, you have to parse the XML. I mean, so the browser takes care of that, and then you walk it. Use the browser's API to actually walk it, which is nice. You get all this nice correction of the data, and the parsing engine takes care of everything. Whereas if your shapefile is malformed, you're in trouble. We can actually take a look at the different file formats here. Here's the KML, and it's about what you would expect with KML, just lots and lots of coordinates. But what's kind of cool is we can come over here and see the binary representation of the shapefile, and this is what we're loading. And so you don't have to deal with a bunch of kind of XML, I don't know what you would call it, verbosity. So it's nicely packed into this binary data. On the other hand, it's very much like load this byte. And in that byte, it describes how many of the next bytes are going to be, into this coordinate, and then, and so it's right now it works. I have to say that it works pretty well. Using what's called a data view, which is kind of an Indian independent view of this data, whereas array buffers are Indian dependent, which doesn't really matter right now, but someday computers might, switch again and or you might have something come over the network, which is the opposite of what you expect, and so data view takes care of that for you. And there's a bunch of different nice libraries that deal with that sort of thing. So
so definitely. I mean, based on current experience, I would say if you were doing a project and you just wanted to display data that you already had, I would pre-triangulate it and push it down to the browser and do it that way. But this would allow you to do things like have people drag and drop their own shapefiles onto a map to view what their own data would look like in conjunction with yours, for instance. So this is a good technique. We're going to work on refining these libraries to get them so that we have a better triangulation. We can handle polygons with holes, and also increasing the performance.
So triangulation is good. Simplification is good too. WebGL has pretty amazing performance, but it's not magic. If you have 500 million polygon or triangles, it's not going to run very well. But if you can simplify that on the server side or beforehand, you make that a whole lot easier, and then you can start doing fun things because you have a large performance window left for you where you can start styling things and animating things and doing all sorts of craziness. So, Mano, we're getting close to our time here. Do you want to talk about kind of a higher level view, like what kind of, why is this interesting? Like why would we want to do this sort of thing as opposed to just loading your KML through as a KML layer?
So one thing to think about is this sort of difference between server-side rendering of layers and client-side rendering. And server-side rendering gives you tremendous power. You can push down the pipe just the bare minimum of exactly what you need, and then the browser and the computer that it's running on don't have to do any work to figure it out. It's usually just displayed as some sort of layer or image layer. In the case of KML layer in the Maps API, it's a clickable raster. But if you can do something on the client side, then it can actually be dynamically interacted with. You can change the data, change the coloring, change the display of the data, do queries on it without having to requery the server and pass data back down. So these are kind of the trade-offs you're making between client-side and server-side rendering. So yeah, I mean, obviously at Google we're very committed to the cloud and having lots of that sort of processing happening there. But I think with the power of the browser and the new APIs you get with the HTML5.
Yeah, we can't ignore it.
Yeah.
It's still there.
Yeah, and it puts I think we're going to continue to have this sort of dynamic tension between client and server side rendering.
Do we want to dare do some live coding here?
Do we have time? Do we have any YouTube questions at this point?
I don't believe so.
We do. We have.
Oh, we do.
YouTube
I'm just kidding.
questions. Okay. Why don't we take?
Yeah. So let's take a look. So what were the names of those JS libraries?
JSTS.
We'll link them in the comments when we post this video.
Right.
But for now,
JSTS for the JavaScript topology suite. It's a port of the Java topology suite. There is shp.js and dbf.js, both of which are on GitHub. And I think those are the only ones that we've mentioned. There's the one we're working on porting on when we get that out, but that's part of the old OpenGL code.
Right.
Yeah, it's a port of old C code. So, is there another question?
Yes. Moral of the story may be better suited to points and lines.
Possibly. I mean, points are things that we've played with and have been obviously really powerful. But I think polygons. Once we get the triangulation right, I think that the polygons are going to give you a lot more powerful representation of the data. But yeah, I mean, clearly points and lines are less computationally difficult than triangles.
Right.
Right.
I mean, so yeah, so I would say they're less difficult. You can filter on them more easily because it's a discrete point.
Right.
But if you want to show an area, then there's nothing. I mean, you can try and do some kind of heat map effect, but that's not always appropriate. If
Right.
you want to show like the difference between neighboring zip codes, like sometimes that's the granularity of your data. So
yeah.
So it really depends on what you're doing. So I think that's the only questions.
And
Yes.
we'll check back if there's any more questions later on the video. We'll check back in the next day or so for more comments.
Yeah, that sounds good.
Cool. Do we have time for your live code?
Yeah, I think so.
Exercise? All right.
So here, what I'm doing is showing you why we might want to do this sort of thing in the browser. I'm thinking shader code here. We don't need these. So what I'm doing is I'm gonna loop over these records, these zip codes, and just change the colors live. And if I don't mess this up, then oh yes, right. So I'm just looping over these. I'm taking the color, I'm turning them green, and then I need to do CanvasLayer .schedule update. So CanvasLayer by default doesn't redraw the screen every time.
Mm-hmm.
Right now I haven't moved the map at all. There's no reason to redraw. So I can call schedule update, and that will make it so.
Right. And that, of course, requires no server calls or anything. It's
right.
just happening right there live in the browser.
And there's no reason why this can't be dynamic. This doesn't have to be a static number. So I could do I divided by 100 and just make sure that that is capped at 1, and now I can count up to full green based on the index within that array. This is using the index, but this could very well be population. This could be anything, and it doesn't have to be green. It could be some combination of colors. It could be polka dotted. It could be anything you want. But the point is that it's it's pretty much instantaneous here. There's nothing holding you back from anything you want, which is pretty exciting part of WebGL. So, all right, so that gives us kind of an idea of where we are right now. Did you have any last thoughts before we wrap up?
No, we'll continue to work on this. We'll push out some changes in the next couple of weeks. We'll push out some samples around this that you might be interesting to monitor the Google Plus page and the Google Geo Developers blog.
And when we post the video, as we said, check the links in the video description, and we'll post them on Google Plus. Probably you can check out different libraries we talk about, including if you go to the Maps v3 utility libraries, you can check out CanvasLayer, and it has some simple samples in there to get you started. And we're eager to see what people come up with.
Yeah, cool. All right.
Thanks a lot.
Thanks a lot, guys.